Okay, hi everyone. We're reviewing for test number 3. So I'm going to go from the beginning all the way to the end. Hopefully I can cover this within like the 20 minutes. Hopefully this is review for you. If you've been keeping up with the homework and keeping up with the lessons and paying attention, this shouldn't be a very hard chapter for you. Remember, if you need to log into Big Ideas, go through the Schoology page. Okay, so log into Schoology. On the left-hand corner, you'll see a link for Schoology and go through there. That's how it automatically logs you in. If you can't log into Schoology, go ahead and click Clever and log in using Active Directory, and then you can use your MyMail account there. And hopefully that would work for you. If it's still not working, please again let me know. If that isn't working, let me know and I'll get the school tech to come help you. Okay. All right, so our goal is to graph lines. And if you look at the website, I've also included a list of topics you need to be able to do for test 3. So under test 3, there's a list of topics. So graphing lines, so we had a couple forms. We have something called standard form. We had slope-intercept form. And then we had point-slope form. I would say point-slope form is the most useful, but most difficult. Most common is slope-intercept form. This guy here is the most common. We'll give him give him triple star, like for popularity. This guy is a double star, and standard form is a single star. He's the least popular, and I would say one of the least useful, but one of the easiest to graph. So let's go ahead and graph things from these 3 different styles. If I write something standard form, remember this was ax plus by equals to c, where x and y, that's the key features, x and y are on the same side. So when we had something 3x plus 2y equals to, let's say, 12 here, in standard form, one cool thing is that we could solve for the x and y intercepts. So I'm going to write this on top, x intercept and y-intercept super fast. These are the key points here, x-intercept and y-intercept. Because I'm looking for the x-intercept, I'm looking for what x would be when y is 0. So the x-intercept is what is x when y is 0? So all you do is you plug in 0 to y. And when you do that, take your finger, cover up the y, and you're just asked 3 times what is 12. Because y is now 0 and now, that's gone off the planet. So 3x equals to 12, divide by 3, x is equal to 4. So we know our x-intercept is 4, 0. Now on a graph, so I'm trying to do this vertically, 4, 0, 1, 2, 3, 4, we have a dot already. To find the y-intercept, that's when x is 0 and what's y? So we plug in x is 0 now, so 3 times 0, that goes away, plus 4, that was a 2y, I think, right? Forgot. I think that was a 2y. Yeah, that was 2y. Plus 2y equals to 12. Well, that's gone now. So it goes to 2y equals to 12. You can do this in your head. 2 times what is 12? Y is equal to 6 because we divide by 2 to both sides. Remember to show work. On the test, you will receive points for showing work. But if you don't show work, I think these are magical answers and I cannot give you credit. And that is something that I've been upfront about with you guys. If you do not show work, I cannot give you credit. So even if you can do this in your head, I still need to see the work. 0, 6, if x is 0, y is 1, 2, 3, 4, 5, 6, put a dot, and we can draw a line. So one thing about standard form, you can find the intercepts very fast. And this is what the test will ask you also. It will ask you to tell me what the x-intercept and what the y-intercept is, as well as being able to graph this problem. So again, very useful for us to be a graph. You do not need to show your work for the review, but I would say you should be writing it out, because on the test, if you're not used to writing the work, of course you're not going to be able to do so. You'll get confused. And what if you make small mistakes? All of us are prone to small mistakes, like let's say the negative signs. And negative signs will be a big deal on this test. So if you mess up on the negative signs, it's probably because you just, oops, I forgot. A lot of you guys, when you guys also are showing the work, you're not showing all the work. Like you're not being detailed about it. So make sure you do show the work, because as I've been going over retaking, correcting retakes, I see people not writing equal signs, not writing plus and minus, and that's leading them to the wrong answer. But you do not have to email me your work, no. Okay, let's look at the next popular form, slope-intercept form. Now, this is y equals to mx plus b. A key feature to know here is that when something is y is equal to, it is almost always already in slope-intercept form. Okay, standard form, x and y are on one side, but for slope-intercept form, y is by itself, which is great. So if we see y by itself, we know this is going to be in slope-intercept form already, barring any simplifying. So one thing that we know is m is what we call slope, and b is our y-intercept. So we're just really just decoding what's here. The Lego pieces are whatever is in front of the x, that's how much we're changing by. That's our slope. And our b value is our starting value on the y-axis. That's called the y-intercept. So let's go ahead and give you guys a problem. Y equals to 2x plus 3. So we see our slope is 2. I'm going to say 2 over 1 to make my life easy. And b is equal to 3. Now, when this comes to a graph, we're already graphing, right? We're already here, graphing. The y-intercept is the y-axis going up and down, and that's going to be positive 1, 2, 3, put a dot. And the slope is always referred to as rise over run. So we always rise up by 2, run by 1, and that's our line. I know that was really fast, so let me do this one more time. We first graph the y-intercept, which is 3. That number is 3 here. Not x is 3. This is the x-intercept. So do not mix those up. A lot of kids will start here, and that is 100% wrong. Details are important. So detail is that my y-intercept is 3. Put a dot here. Then we climb the rise over run. We rise by 2. 1, 2, and we run by 1. Rise is up and down. Run is left and right. Positive means up, of course. And run, positive means to the right. So we have our graph. Now, a couple of things about this, when we introduced slope, is we had a magical formula for slope. Slope is rise over run, yeah. But it's also, you can look at it as x and y points. y2 minus y1 over x2 minus x1. We're just subtracting the y values from each other to figure out what the rise is and the run values from each other. Now, when you look at this as points, if I say 1, 5 and 2, let's say 4, okay, what is the rise? Well, is x or y rise? Is x or y rise? When I go up and down on the graph, that's our y value. So our rise, oops, let's do that. Our rise is our y values. And our run is our x values. Now you tell me, from 5 to 4, did we rise up or rise down? 5 to 4, I would say from 5 to 4, we went, whoops, other way around. From 5 to 4, we went down, right? 5 to 4, 5th floor to 4th floor. So we say 4 minus 5 is equal to negative 1. That's my rise. How about my run? Well, we went from 1 to 2. 2 minus 1 is 1. So our slope is negative 1 over 1 or negative 1, if you want to simplify. So if I'm given 2 points, we can find the slope of those 2 points by just subtracting the y's from the x's. Just make sure you stay in the same order. You have to go 1 point this way or 1 point this way. You pick one to be first. Someone has to be first, right? Might as well be you. And then our last example here was our point slope form, which had a form of y minus y1 equals to m, x minus x1. Now the x and y1, that's my point, right? That's my point. And my slope was m. Now this is the same slope as this guy here, same slope. Okay, same slope. And let me give you guys an example. Y minus 3 equals to 1/2 x plus 2. Now, you have to be able to decode this, right? It's in the right format, but we have to make sure we can see the parts. And let's look for our point and our y and our slope. So our point here is that's my x1 and my y1. But careful, as you see here, these are already negatives. In the problem, these are already negatives. So it's almost like there's a negative in the wall. So what is the value here? That's going to be y is 3. So my point is y is 3. But the point here isn't positive 2. It's actually a negative 2 because x minus negative 2. That's how we end up with that positive. And that's one of the things you pick up after you do these problems over and over and over again. You realize, hey, the negative is really a positive. So now our slope, that was given as 1 over 2. Now, we graph what we have. We have a point and we have a change from that point. So the point is negative 2, 1, 2, 1, 2, 3, negative 2, 3. And then the slope is rise 1, run 2. Then we have our line. Okay, I know I did that too fast, right? Because it can't be that easy. And it really is that easy. We start off with our point, and our point is negative 2, positive 3. And then our slope, our change from this, is rise 1, run 2. Because I identified that. Rise 1, run 2. And that's our slope. Okay, we continue this. Now, we mentioned before that, as you can see my stars, slope-intercept form is the most popular form here. So we're going to change standard form to slope-intercept form, and then we're going to change point slope form to a slope-intercept form. We're going to do these two. Right now, we're going to practice that. So as we started off before, we said 3x plus 2y equals to 12. And we're going to change from standard form to slope-intercept form. Okay. Oh, sure. One more time. How did it become negative? So over here, if you remember, this is y minus y and x minus x. That's like the statue. That's the portrait. That's the frame. So if I write y minus 3, hey, y1 is just positive 3. Okay. So if I stick a 3 here, we would end up with y minus 3. But over here, you see x plus 2. Well, it's supposed to be negative. It's supposed to be negative. So x is not positive 2, it's negative 2. Because a negative and a negative force it to become a positive. So let me give you one more example of that since we're here. Y plus 5 equals to 1/2 x, let's say plus 3. So I made them both positive in this case. But remember, it's supposed to be y minus y and x minus x. So what is y1? Y1 has to be a negative 5. That's how we made it into a positive. And x has to be a negative 3 because the negative become a positive. So the x and y here is negative 3 and negative 5. Careful, it's always x and y. and sometimes you might flip it on accident, it will give you a whole different point. Do you need another example? Cool. So that's why we have to be careful with the form that they give us. And when we add numbers to it, sometimes they do have to flip. Okay, let's go ahead and change our standard form to slope-intercept form. So we are going to solve for y. And that's the only thing that we want to say. Slope-intercept form is y equals to mx plus b. And we're solving for y. Get that y by itself. So just like we did when in the first week of class, I joked around with you, is that if this is you, y, and you want to, and your family members are all in your room, they're having, hey, I haven't seen you in a while, let's go hang out. And you're like, nope, I got some stuff to do. Do you get rid of stuff that's closest to you or farthest away? We get rid of stuff that's farthest away. And this is a plus 3x, so we minus 3x to both sides. 2y equals to negative 3x plus 12. Now, one more step, I need to get rid of that 2. What is the 2 doing to the y? Adding, subtracting, multiplying, dividing. And if there's no sign, it's multiplying. So we divide both sides by 2. I'm going to divide everyone by 2 here. So y is equal to negative 3 over 2x plus 6. Now, would this be the same graph as the one we drew? Well, the y-intercept we said was 6. We have 1, 2, 3, 4, 5, 6. This is 6. That's my y-intercept, yeah. And my slope is negative 3 over 2. Negative 1, 2, 3, 1, 2. Negative 1, 2, 3, 1, 2. I kind of fudged that, but yeah. That's the same line. A question was asked, how many questions will be on the test? The questions will be at most 20 or at least 16. So anywhere between 16 and 20 questions. As you go through the review, you'll see some of these questions are actually really easy. If I give you standard form, I say identify the x-intercept and y-intercept, that's like a 30-second question. That's us plugging in zeros. If I ask you to convert something from standard form to slope-intercept form, this is what, a minute, 2-minute problem? So the questions aren't super intense. Some questions are just saying, label the slope, or tell me what the slope is. Count the rise over the run. So about anywhere from 16 to 20 questions. So we're going to go on the right side now. We're going to go from point slope form to slope intercept form. So let's say y minus 3 is equal to 2. Whoops. Oh, we actually let's do the problem that we did have. We did the problem up here was y minus 3 equals to 1/2 x plus 2. Okay. So for this problem, we're going to have to to get rid of the parentheses. There's no parentheses in slope-intercept form. So let's distribute y minus 3 is equal to 1/2 times x is 1/2 x, and 1/2 times 2, 2 times 1/2 is 2 over 2, which is 1, plus 1. We're almost done here. Solving for y, opposite of minus 3 is plus 3 to both sides. Y is equal to 1/2 x plus 4. So we graph this problem. 1, 2, 3, 4. And our slope is up 1 over 2, up 1 over 2. And this line looks like my last line, except they went backwards. They went down 1 and then back 2. And that's what their point was. I think their point was negative 2, comma 3. All right, the last point of the test, the main point, was using what we've learned here to write parallel and perpendicular lines. Now we describe parallel lines as lines, of course, that don't touch, right? And that's very easy that we've seen before. But why don't they touch? Is because they both have the same slope. So if I say this slope is 1 over 2, the slope that's parallel is also exactly 1 over 2. They have to be exactly the same. They can't be close, but they have to be exactly the same. If they weren't close, they would eventually run into each other, given enough time. So how do I tell lines are parallel? Let's go and look at these two examples. If I say 2x plus 3y equals to, let's say, 6, and y equals to negative 2 over 3x minus 5. Is line 1 and line 2 parallel to each other? Okay. Is 1 parallel to 2? Right? And that's a question. Is 1 parallel to 2? Well, we only have to look for one thing. If the slopes are the same, well, look at line 2. Do we know what the slope of line 2 is? The slope of line 2, mx plus b, m is negative 2 over 3. And that's how we learn these forms, because we can identify the special parts without really doing any work. Identifying the special parts is the work. So I want to make sure you guys write 2 over 3. Now the top equation, is that parallel to negative 2 over 3? Well, that's not in slope-intercept form, so I can't see the slope right away. So let's go and change this to slope-intercept form. We change to y equals. So to do that, let's get rid of the 2x first, and then we'll get rid of the 3. So 3, we're going to minus 2x to both sides. So 3y, let me give you some more space here. I'll do this over here. 2x plus 3y equals to 6. I'm going to minus 2x to both sides, we mentioned before, because we want to solve for y. 3y equals to negative 2x plus 6. And we're going to divide both sides by 3. And the way I teach the method is to divide everyone by 3. Y is equal to negative 2x over 3 plus 2. And then now we have the slope. M is equal to negative 2 over 3. And they are equal to each other. So yes, these lines are parallel. So no matter how you're given, whether equations or points, we want to make sure we have the same slope. That's how we know they are parallel. Perpendicular lines, though, are not the same. Perpendicular lines are a negative reciprocal. Means a negative flip, right? In common English, it's a negative flip. So if my slope was, let's say, 1 over 2, the perpendicular slope, denoted by this upside down t, is negative 2 over 1. I'm going to show you a different method to check this. If I give you the points 1, 2, and let's do 2, 4. So this is line 1, and line 2 here is 3, 5. And we'll call this 1, 6. Are these lines perpendicular to each other? Well, we only have to look at slope. So the slope here is y2 minus y1 over x2 minus x1, sorry. So it's going to be 4 minus 2 over 2 minus 1. We subtract the y's from the y's and the x's from the x's. We end up with 2 over 1, positive 2 over positive 1. Well, if this is perpendicular, this better be negative 1 over 2. That's a perpendicular slope, a negative reciprocal. So let's see, 6 minus 5 over 1 minus 3. Do we end up with perpendicular slopes? Right? Y minus y, x minus x. 6 minus 5 is 1, and 1 minus 3 is negative 2. And you can always write a fraction. If you haven't learned this before, a negative, you can write the fraction on the negative in the middle, if there's only one of them, or on the top. All these three forms are exactly the same. They're equivalent to each other. And yes, they are perpendicular by looking at the slopes. The last part here, sorry, I'm running out of time, is to write an equation given this information. If I tell you So write an equation. Let's say a parallel line equation. If I give you equation y is equal to 3 over 2x plus 4, I want you to write parallel, parallel at point 2, 5. So I want you to write a line that's a new line. Here's my new line, parallel to our old line, but crossing through this new point. Now that means my new line needs point 2, 5 and slope 3, 2. Why did I choose 3, 2? Because if they're parallel, they have to have the same slope. And see, that's all logic we're trying to lead you guys to in Algebra 1, saying if these have the same characteristics, they have the same common values. What common values would that be? And you have to come up with that yourself. Everything can't be force-fed to you anymore. If you guys are going to college, right? College is all about self-learning, just self-discovery, about why is something true. And we have to fight for that. It's not just fed to us. So we're given a point and slope. Now we have a version of a line with that, point slope form. Y minus y1 equals to m, x minus x1. So we fill out y minus 5 is equal to 3 over 2, x minus 2. Because we were given a point, that's my x and y, and my slope. So we have this new line. So read the directions. If they want you to leave it in this form or change it to slope-intercept form, I'm going to go ahead and change the slope-intercept form. We practiced that before. Y minus 5, we're going to multiply 3 over 2 in. So it's going to be 3 over 2x, and 3 over 2 times 2, a negative 2. The 2's cancel. We're left with negative 3 and 1, which is negative 3, minus 3. And then plus 5 to both sides because I'm trying to solve for y. Y is equal to 3 over 2x plus 2. And that is my new line that's parallel to my old line and goes through the new point 2, 5. And that's our culminating task. You do the same idea for perpendicular, but for perpendicular, we would change the slope from 3 to 2, becomes perpendicular, negative 2 over 3. Okay. And that is test number 3.